Hello. So my name is Josh McCarty, and I work for a small company in Nashville called Urban 3. And I'd like to tell you a little bit about the work we do and kind of shift gears and talk more about the application of using 3D. It's very integral to the work we do, and a little different in that we focus on the more using 3D to explain more abstract concepts. So we live in a time when it's easy to accumulate vast amounts of information. We measure everything. We measure things about the environment, human behavior, economic behavior. But the trick is to be able to find the signal in the noise and to further synthesize that into something that a person without the right context or expertise can see a single image and understand what's important. So that's the challenge that we try to put on ourselves in conveying information to local communities. And what we work with is we work at this intersection between public policy, urban design, and economics. And specifically, what are the rules that lead to the pattern of development in a city, the kinds of development that it has, its urban format, and how does this impact its ability to produce revenue and how efficiently it can produce property tax revenue. And we deal with property taxes primarily in parcel data because it's the backbone of local revenue. It's the backbone of the local budget. If you look at local budgets all across the United States, property taxes are always an important piece of the puzzle, sometimes the important piece of the puzzle. And if you take all of the revenue generated locally by all the cities in the country, or cities, counties, and schools, local governments, about half of it comes from property tax. There you go. Here's a 3D representation of data, which is an excellent example of how not to visualize data in 3D, since this lozenge of a pie chart not only manages to not add anything to understanding the data, it actually distorts the sizes of the pie wheels. So I just like to set the bar low when I'm starting out. They'll get better. They have to. So what we try to do is get cities to think in terms of a large corporation. Not that cities should be large corporations. There are fundamental differences. They provide public goods, but they should be making fiscally prudent decisions and growing their wealth and providing financial security for their future. We often forget exactly how big our local governments are. So what I did here is this is a chart where I put along side by side some of the counties where we've worked with Fortune 500 companies by total tax value and market capitalization. So to just make the point, Buncombe County is about the same size as Dell, or Wake County is about the same size as Philip Morris, or Boeing is about the same size as Gwinnett County, Georgia. So if you think about these big corporations and the kind of planning and strategy and financial analysis they do to make sure at the very least they're going to be solvent, but also continue to grow and produce revenue, are local governments making these same kind of plans. So we like to think of ourselves as sort of a portfolio analyst for local government. We try to get cities to think in terms of a business, but we also try to get them to think in terms of farmer. Because what is a city but a finite amount of land that's delineated from which a city draws its revenue? And much like a farmer, a city needs to pay attention to what its crops are and what is getting the most revenue bang for its buck. So this analogy, what are the fields? What are the crops that we're talking about? Well, here's a little example from Asheville. 3 options of development choices that Asheville has. There's 3 types of buildings: a big box retail, Walmart, and a mixed-use downtown building, and my boss's house. And cities and decision makers often get distracted by this big number, $20 million. That's the biggest tax number on the board. But any good farmer knows it's not just the money that you get from a crop, it's how big the field is. And it took 34 acres to produce that $20 million. So when we normalize the information and take into account the amount of land it takes up, the size of the field, the house produces $20,000 an acre, the Walmart produces just $6,500 per acre, and the downtown building knocks it out of the park at $600,000 per acre. So thinking like a farmer, these are the crops that a city has available. This is what it can do with its limited supply of land. And we did this presentation in Colorado. We might want to make it really simple for people. So we asked them, if you're a farmer, what would you grow? Colorado, right? So I put it a different way. When you're shopping for a car, you don't typically, the first thing you start comparing is the miles per tank. Range is important, but most of us can find a gas station within the range of our gas tank. So if we were concerned with the miles per tank, we would go with the F-150. But usually we're more concerned with the amount of gas we're going to have to buy in a year because that's the finite resource. So we compare efficiency, miles per gallon. So what we wanted to do is try to think cities to think in the same way about their real estate. In that case, you would go with the 55 BMW Acela. So we did this presentation in Australia, and we realized we had to switch the vehicles up so they would make sense to an Australian audience. So we did our research, and we realized that this is the kind of vehicle that was going to make sense to an Australian. You go with the Mac R600 with a cow catcher and a bunch of spikes on it. So we've done this kind of analysis all over the country, and in New Zealand and Canada, and we found the same pattern everywhere we looked, which is that the more stuff you can concentrate on a site, the more buildings you can put on the same amount of land, the more tax revenue you get out of it. And you don't just get more tax revenue, you get exponentially more. So I want to go through the basic concept first and kind of lay the groundwork for why it is we use the 3D imagery to tell this story. Because we can explain the concept, but to show it on a map and to go further and show it in 3D, you can really get people to understand how their city functions. So we like to think of it, just as we have these tools in medical technology to look inside the body and see what's healthy and what's not. We like to think of what we do with these visualizations as sort of an economic MRI. So let's take a little case study from good old Normal, Iowa, with its wonderfully well-organized data. So this is our total tax value map of Des Moines, of Polk County. And this is we can think of this as a per tank analysis, just the total taxes produced. And it doesn't tell us a whole lot. In general, the bigger things are just worth more. But when we normalize for the amount of land consumed, we can see that there's a more understandable pattern of development. But it's still hard to tell exactly what's going on. One of the big problems is that the most important things on the map are by their very nature small, so they're hard to see at the full scale. Now we can zoom in and see that there's a lot of tax potency in the downtown, but you lose the context of the overall pattern. And we got some tricks we can do in the 2D world to try and make up for that, like the cartogram. Whenever I show a cartogram, I always feel like kind of a magician. I feel like I should have a top hat and a cane. It's sort of like a magic trick, like a gimmick. But we can distort polygons based on the value, the shape and size based on value. You can see how downtown expands and things of low value contract, and the whole county sort of inflates like a balloon. But there's so much distortion in this that you really, it's just sort of makes a point. You don't really get the full picture. So what we like to do instead is we'll take our per gallon or value per acre map and put it in 3D. Now you can tell me where downtown is. Big spiky thing, right? So what's great about visualizing abstract data in 3D is that you can immediately spot patterns without knowing a lot of interior information about the place. So you can spot geographic features. You can figure out where the corn is growing in Des Moines, which is Iowa, so pretty much everywhere. You can see the extent of development, how far out the dense development extends. Some of the other more practical advantages are in our 2D map, it's not really possible to tell how much more purple one thing is than another. We're limited by the classifications that we have. But in 3D, we can see that everything purple is above $10 million per acre. Well, I can just tell you if I can read it. But you can't tell whether it's 11 million or 50 million. But in 3D, you can tell the difference between a short purple and a tall purple. The other thing that it accomplishes, or at least addresses, is something I feel a little guilty about, which is that I've been told that a diverging red-green color scale is not exactly ideal for people who are red-green colorblind deficient. And so at the very least, if you can't really distinguish red and green, you can see what's tall and what's not tall. All right, so we can use the same idea to apply it to other metrics. So in this case, taking the same information and looked at it at the census block level. And here we have, this is zoomed into downtown Des Moines. This is taxable retail sales. So you see whether or not it's the same pattern. Basically is. And here's property value again. And here they are combined. You can see they kind of flow in the same direction. Population density, a little more distributed, not quite a strong pattern. When we get to employment density, anybody know what's based in Des Moines? Wells Fargo. So there's a quarter of all the jobs in the entire region are located downtown Des Moines. So pulling these things side by side and showing them in 3D lets us sort of understand where our patterns are correlating. So another one of the most interesting projects we've done in the last year was Charleston, South Carolina, which is interesting mostly because it's got interesting geography and its coastal line, but also because it's got a well-preserved pre-modern pattern of development. In a lot of ways, it's still a colonial city in its downtown, which I'm guessing you can spot again. This was exciting for us because it's an opportunity to compare how that old model of city building relates to tax production. One of the other things that showing data in 3D allows you to do is it allows you to free up the symbology to tell another part of the story. So in this case, the height is still showing us value per acre, so higher, more tax potency. But the coloration is telling us the age. So in one image, we can start to see the pattern, almost like tree rings, as Charleston grew out from the center. And as it did so in a less compact, less tax efficient manner. So in one image, we can see geography, we can see space, time, and value. We go a step further. There we go. And look at it as it happens. So what you're seeing is an animation that we made that shows the tax value as it comes online. And you can see it's not even 1900 how much of Charleston's tax value is already built in the ground. And something interesting is about to happen. We're about to invent cars and highways, and you can see how the development pattern changes rapidly as Charleston grows inland, and develops the beaches. So one of the fun implications of doing this project is that Charleston actually has buildings with the unique distinction of having paid taxes in, well, technically 2 other countries, but predating the Declaration of Independence. And here's an example of that. This is the oldest liquor store in America. It still has colonial people who frequent it. And so here's what that development looks like. These are just the buildings that are older than 1776. And so you can see how potent the ones downtown are. So we made this comparison, and we found something really interesting. Here, let's just focus on the ones in the Battery, or in the downtown Charleston, for a second. There's about 21 acres of these buildings that are older than the United States, which happens to be almost the same size as the Walmart over by the Tanger Outlet out by the airport. So we got two examples of 21-acre development in 2 different fields, 2 different same-size fields in their portfolio. But the Walmart paid about $47,000 in county taxes last year, while at 21 acres of pre-1776 buildings paid about $600,000. So you think about that for a second. You've got buildings that will last generously 20, 25 years, producing $50,000 a year, versus buildings that are already 240 years old, producing $600,000 a year. This is the kind of thing that we try to add to the conversation that cities are having about their development and urban design and the kind of future they build for themselves as they develop. There's another fun example from Buffalo, New York, where one of the fun things that happens in doing this, when we put the data in 3D, is we find patterns that we weren't actually looking for. It's actually a really great exploratory tool, because once we see the data this way, there's all sorts of stuff that we didn't expect to find. And this is one of my favorites. So I did the model for Buffalo, and I noticed these, make it easier for you to see, these concentric, almost ring of spikes, these super high valuable properties that weren't really where I expected them to be. I thought maybe it was an error at first. So we went to them. We actually drove these and to see what they were. It turned out to be these identical brick buildings owned by the utility, transformer buildings, which that wasn't totally surprising. But what's surprising is exactly how valuable they were. These things were worth, you can see there, $20 million an acre, $5 million an acre. For the sake of comparison, here's a beautiful Victorian house in the nicest neighborhood in Buffalo. It's across the street from one of these. It's like $1 million per acre, right? So what it turned out is from seeing this pattern in the 3D model and exploring further to figure out what the story was behind that. Niagara Falls is still a massive hydroelectric power plant, and upstate New York has some of the cheapest electrical power in the country, except for Buffalo, where they have this centuries-old, long-standing feud with the power company over something. And so what we might be seeing in this case is parcel-based retribution for Buffalo, New York's really high electrical bills. Upstate Buffalo is an interesting place. So one of the advantages that we have in doing this work all over the country is learning lessons from different places and being able to apply them and bring those lessons to other communities. And one of the most illustrated cases that we've done was Gwinnett County, Georgia. Anybody know where Gwinnett? Anybody from Gwinnett or at least know where it is? So it's part of the greater Atlanta area, but it's having sort of an identity crisis, coming to terms with that and coming to terms with exactly how much a part of Atlanta it really is. So when we did our work there, they told us that we shouldn't use certain words that might upset politicians and upset certain people in the community. Words like urban, city, town, or municipal, which was a little awkward when we had to say our name. But one of the things that's interesting about Gwinnett County is that Gwinnett County has almost 1 million people. But it's a big county, and that was their argument. We have a lot of people, but we're really spread out. We're just not a city. We're not dense. But it's partly just denial, because when we look at the numbers, they're not as dense as, say, DeKalb County, but they're denser than these places. It somehow managed to develop in a very low-density way or medium-density way, but had done it wall-to-wall across their entire county. So they ended up more dense than Charlotte, Nashville, Raleigh, Austin. This is kind of mind-blowing to us, and I think really mind-blowing to them. But what was especially surprising about it, so here's their value per acre model in 2D. When we put it in 3D, it didn't look like any of the other models we'd done before. Who could tell me where downtown is here? It's the first one where we couldn't really answer that question, because they had somehow managed to develop across their entire county without ever developing a nucleus or coalescing that development around a single point where there's a real cluster of value. And so we were looking at this, and we put the model on its side and realized it looked like a shag carpet, which was really different from what we're used to seeing. So anybody want to guess where this is? Should look a little familiar. It's Chapel Hill. And I don't even need to ask you where, if you see downtown, you can pick out the individual places. There's Chapel Hill, Carborough, Hillsborough. And so Chapel Hill in Orange County is much smaller than Gwinnett County. But just to put this in perspective, we laid the model flat on its side and compared it to some of its contemporaries. Gwinnett County has 800,000 people. Nashville, Davidson County has 600. Travis County has 1 million. So it should be roughly comparable to these. But look at the difference in their height. And you can't quite see it, but the reason Austin's way down there is because it goes way up there. And if this was a heart monitor, we would probably be pretty concerned about our Gwinnett County patient, right? Now it's population-wise, it fits in the middle between these two, but look where they peak out: 200 million, 500 million, 8 million. So doing the 3D model showed us there's something not right about development and the pattern of development in Gwinnett County. Just to bring it home, these are these places that are less dense than the places that told us that we couldn't say the word city. And look at the difference in their peak values. So far I've talked about the revenue side of the equation. And I'd like to just talk a little bit about the experience that we had in Lafayette, Louisiana, where we were asked to look at the cost side. I'm guessing someone in here has been wondering, what about cost? And the reason that we did this work in Lafayette, Louisiana, of all places in the country, is that they've had bad experience already with the fiscal implications of the development pattern. This is their budget document from 1994, which I think you can tell the finance officer thought they might have a problem. 1995, lightning strikes twice. But fortunately, in 1996, they merged with the city, fired the artist, got some flip art, and everything was fixed forever. / they kicked the can down the road, and now they've caught up with the can. And so they're having some financial issues. So I just want to look at one of the layers of cost. What they asked us to do is go through all of the kinds of costs, infrastructure and services that we could think of to distribute spatially to figure out what the difference is in cost between more central and compact development and their newer, more expansive development. And I just want to look at one of these, which is probably the most important one, which is their road system. There's a road system, about 1,000 miles of road, and just as a thought experiment to get people to understand exactly what the liability is they're facing, we decided to think of their road liability as one big parking lot, which would be about 6.5 square miles if you combine all of their locally maintained road together, and something like $8 billion to repave. So that's what they have to do every 50 years. That's the cycle that they're on, plus whatever they decide to build in the meantime. To put that in perspective, if you floated it over New York, it would take up all of the harbor, or closer to home, if you stuck it next to New Orleans, that's how big it would be compared to the city of New Orleans and the French Quarter. So here's their revenue model. And you can see it looks pretty typical for American City. You can find downtown. We've got kind of a sub-downtown. And I'm going to kind of skip through to the punchline on this, which is we went through and modeled the costs and the revenue, and this is what it looks like in 3D. And so we net it out, subtract it out, and you can see some property is producing positive revenue, some property is in the red in accounting terms. It's just at a different angle, and you can see that the more central stuff is in the black, and the things further out from town are in the negative. And it's just the same image showing both in the positive. With that, I'm turning yellow here. I'll just go to this slide and say, I think what's really amazing about showing the data in this way is that taking people who may have never have seen this kind of data before or aren't even familiar with the community we're talking about, we can put the information on a map like this and show it, and you can immediately understand a lot of really important things about it. And so here's a little gallery of 3D models. And there's a lot more that I could talk about and get into in some of the more recent stuff, but I will leave there before she threatened to get the big hook. Okay. I will say that this was an excellent pairing of presentations, and one of the things that I didn't put on here because I didn't want to add too much complexity to try and click around things is we have started using, we really started taking advantage of web scenes, which is fun because you can take one of these models and put it, we're pairing that with story maps. So one of the cool things that Esri has is a template to be able to take all the stuff that we generate from our projects, put it into an online document that people can spend time with, learn more about, and especially the 3D model, be able to scroll around, pan around with themselves, click on things, and learn, in more detail where these spikes are, what they are, what buildings under there. So these projects are from the last few years. So we've been using ArcScene to do this stuff because working in the abstract is sort of we have a lot to try to show. So the extrusion works pretty well, but now we're trying to learn transition over to ArcGIS Pro. especially the 64-bit aspect of it is very exciting. Oh yeah. And I'm also excited about the LiDAR stuff I've been seeing today.